Hello, this is Paul from Fast Attack. In this lecture, we are still going to discuss the integration by parts, but this time is for definite integral. The last time we discussed for indefinite integral, right? So here the summary, you will see there's no big difference between these two. Okay, so first, and here the formula for definite integral. Okay, so can you see? The only difference is we put the limits, right, or put the difference from a to b. This is for what? This is for an area on the curve, right? For definite integral. The last time we don't have limit is for the antiderivative, indefinite integral. See, almost the same, right? And also the same if we set up u is f and v is g, and then you can see this form is the common view, right? It's also similar, and only one difference is the AB we have. But keep in mind here, because we have a u is a function, v is a function, like x is the variable. So in this formula, keep in mind that the variable is only x. This AB is for x, AB is for x, AB is for x. The same, when we're going to use this formula, we need to set up a u and the dv, right? We still follow the same guideline. So how do you set up a u? If the derivative of u is simple, then u, okay, or with du is simple. Then how to set up dv is v we can resolve, right? V is resolvable. If here I just show one sentence. If we're going to prove this, all we need is the integration by parts for indefinite integral, right? See, compare these two there. If we get the antiderivative and put the limits, or we say is put the difference from a b. The difference of the functions between a b is this, between a b is that. So exactly we can prove, right? From this to the first, of course they are the same. So you just set up a u and a v. One more here I have to show you. And we said no big difference between this definite integral and the indefinite integral, right? So two integration by parts, no big difference. Therefore, you don't need to exactly use this integration by parts for definite integral. Means what? See, the first method you can directly use indefinite integral, okay, with the integration for parts to find this. Why? Because of what? Because we have so can we see, if the first we use integration by parts to find the antiderivative for this indefinite integral, can we? Yes, we can. The last topic we did, right? And if we have the antiderivative, then how to find this definite definite integral? We just use the fundamental, right? You have the antiderivative, use the fundamental you have. Okay, so this is the first method. If somebody like you can. However, so my suggestion is still ask you go to the method 2, which means this is the version for integration by parts method for definite integral. So definite integral just merge these steps together, okay? So this equals this is another form, and then we look at it, we use this the common view. So this part, so the other part, right? This difficult part can use a uv and minus the easy part, okay? But be sure a b, okay, is all for the variable x, okay, for the single variable. And I'm going to show you another 3 examples, okay, show you how to use this, how to use the common view. Keep in mind it's the common view. We're going to use this form, not to go back to the original. And you will see, and the question is still similar with the last time, okay? So when we deal with the indefinite integral, okay, the first step, can we see this? The easy one, okay? So we still have 2 steps, okay? The first step is set up a u and dv. The second step plug in to the formula to calculation. So the first is setting up. Setting up always the most important. How do you set it? You can set u is equals x or u equals cosine x, we're going to set u equals x. Why? Because x take a divided equals 1. 1 is simple than this. If I set up a u equals cosine, cosine take a divided equals to sine. Okay, we cannot say sine is simple than cosine, right? No, they are the same. So probably you can try by yourself. Okay, I will set up this is u. So this left is dv, and then I will get what is du. Du should be dx, right? I will get what is v as over v the entire divided over cosine, which is sine. Good. So this is the most important that we already set up, and then I just plug into the formula. Okay, so I still copy the formula for you. This time the formula we use this formula. Okay, this is for the definite integral. So I put a b to here. Okay, so this we can separate to two parts. uv is the whole, we simply say, and from a to b minus this part. Which part? Switch u and v, right? Switch u and v and a b. So keep in mind that, so like we simply say this is the whole and this is part 1, this is part 2. If part 2 is easy, and then we can use part 2 to find the part 1. Okay, so that we call the integration by parts. Okay, it's the formula. I copied. This is the integration by parts, but this time is the version forward. Directly, okay, for definite integral. Keep in mind, right? So this is for definite. We have a b here. Keep in mind that we use this formula. Then all we need to do is plug in uv and the du dv. Okay, so what do we have? So here is should be the first. You're going to integration ab is 0, b is power 2, so it's 0 to power 2. U is x, so that's x. dv is that, so it's this exactly same, right? Okay, did the question, and then I'll plug. What is it here? U is x, v is sine x, and then a is 0, b is power 2. Good, and minus. So here is the integration, definite integration from a is 0, b is power 2. V is sine x, and the du is dx. See, and then now you know. The first, of course, we know. The second, this is easy because this is the fundamental. We have the entire variable done, right? Okay, I plug in this to calculation. You get the power 2, and this we use the fundamental. Cos sine, the entire variable is negative cosine. Okay, 1 entire variable from 0 to pi over 2. And this plug in, you have the special value, right? I think you remember all the special values. You learned that from trigonometry. Okay, so use that special value, you get the value. Okay, so for this definite integral is here. This is the first. Can you see? No big difference from the last topic. When we use the integration by parts for indefinite, so the first step is set up. The second step is plug into the formula. You get the answer, right? Still the same, okay? Two more questions here, the second. Can we look at this? Okay, so here I directly tell you. So this is a special case. At the first, you're going to set up, be sure simplify. See, this is the integral is a composite function. It's composite, right? Complicated, but we can simplify. So look at it. The first step, don't do anything before you simplify something. Okay, simplify always the first step. Keep in mind that if you can, always the first step is simplify your question. So we're going to simplify, and this square root of x is x raised to the 1/2. Power, right? The power rule of log, which means the power laid down. So 1/2 go to here, and then integral 1/2 goes to out, factor out. See, we definitely have this one is equal to this 1 to e ln x dx. Can you see this is much simple, right? And then we're going to the normal way, so everyone knows, right? So we're going to set up. We're going to set up how to set up. So this time you see you only one way, okay, to set up. This is u. Why? Because we only have one function. We have u here. Or probably you can say this 1 times this function. You can set up u equals 1, right? But in that way, so dv you cannot solve for v. You can try by yourself. If I set up this way, so here should be dv. Okay, and then we solve for du is what? We find the du. So du equals this take a derivative. Okay, so 1 out of x, right? And dx. And from okay, so here we solve. So here we can solve for v is dv equals dx. V equals what? V equals x. Of course, we don't need to plus c. Keep in mind, okay, so only to get this specific. And then we're going to okay, so here first the coefficient. I will consider this coefficient later. Okay, I mean what? We only find this value first. Okay. How to? I copy the formula to here still. Everybody remember the formula? This is the formula, right? From AB equals UV A to B minus switch the order, so V du, and here's from A to B. That's the formula, and then I plug everything. So of course this should be this. Okay, and we're going to AB is 1 to E. U is lnx, dv is there's dv. Okay, dv is dx. See, I was going to find this value. Use the integration by parts, and this equals what? So this equals what's u? ln x, right? What's v? Is x. Is better. I put the parentheses. You don't mix them together. Okay. A is 1 to e, right? And then minus. So this is the integration, definite integration from 1 to e. V is x. What is du? Is 1 over x dx. See, here is how simple. Okay, the integral functions goes to 1. Therefore, this is easy to get it, right? And then I plug in to get the solution. For the first, you're going to do calculation because here's 1. The second is b minus a, right? Okay, so I put here is e minus 1, and you simplify, you get 1. Okay, I put here. See, 1 is for this part, so this part should be 1/2 times 1, which means the solution for the original, right? So we have the original. I put here one more sentence. 1 to e ln square root of n dx. That's the questions. C equals 1/2 times this term we already get 1 times 1, so equals 1/2. Okay. Look at these questions. Go over little. So only one step. Okay. So I highlighted this step. If you can simplify, keep in mind simplify always at the first step. One more question. Here. Look at these questions. So always, can we simplify? No, we cannot. So we need to go to setting up directly. But this time you probably have trouble. Why? Okay. So look at this one function times another. Look at we have two choice, right? You can set up this u, or you can set up this u. Okay, so let me write here the option. You can set up u equals ex, or you can set up u equals sine x. Can we see any difference? See, look at it. If I set up u equals ex, we take a derivative of u equal to itself. Look, this is not a good choice, right? Because we cannot get a simple for du. Look at the second choice. If we set up u equals sine, and then we're going to take a derivative, what do we get? We get a cosine. We don't think a cosine is also the similar level is not as simple. Means what? So look as we have a trouble, okay? No matter which way we choose, so look as the same. It's not a good choice. Look as is the same. It's not a good choice. However, don't worry, okay? Choose any one of these, and then we go inside, and then we go kind of loop. So you will see later, okay? We're going to use we use the integration by parts twice. You will see a kind of a group, and then at the end resolve equation, you will get what you need. This is very special, okay? So please keep in mind. I will going to just choose this one, any one, okay? Choose the first one. We see I choose this is U, so this should be dV, and then I will going to get a du equals EX dx, right? I will going to solve for V. This is good. V equals negative cosine. Okay, no problem. The only way is du we did not get a simple, and you will see, okay, what does it mean later. Can we we're going to copy the formula, okay, so once again. So the formula u dv a b equals u times v a b minus we have this, okay, v du from a to b, right? Did the formula I copy. So here is the original, should be the original. So it goes to 0 to 1 ex sine x and the dx, okay, equals was here. U is e raised to the x power. V is negative cosine x, okay, it's okay. So a is 0, b is 1, and then minus, this is the definite integral, which is 0 to 1. V is negative, right? Negative cosine x times du is there, times e raised to the x power dx. Okay, so no matter. So let me simplify first, see if we can get a solution. And this you plug in 1, plug in 0 to subtractions, you get a 1 minus e cosine at 1, okay. And this is the first. The second, negative goes to positive. Okay, another. So look at this. Can we get the solution? No, complicated. Almost the same difficult as before. Can you find the solution now? No, definitely not. What do we need to do now? We need to do the integration by parts the second time. But how to set up a u this time? Keep in mind that this is special. We have to set up a u is the same as before. At least we look at the form is very similar. Ex times sine. Oh, I have to switch. Okay, switch. If I switch this ex times cosine, very similar. Okay, very similar. I set up a u is the same. U is the same, and then what do we need to do? So later you will see. Definitely. Okay, we'll get something. You will surprise. They will surprise you. Okay, first I simplify. This means what? This is 0 to 1. I said we switch e raised to the x times cosine x and dx. Look, we still did not. However, I just said I was going to do set up the same. Okay, I set up this u, and this should be dv. Set up the same u as before. Then I will get a surprise result. Keep in mind, if you set up u equals cosine, and you try it by yourself, and then you plug in what you will get. You will cancel all the terms. You get 0 equals 0. There's nothing. Okay, nothing you can get. This is the only way you can get a surprise. So now we focus on this, and then what do we need? We need the du, right? Du is ex dx. We need to resolve for v. Easy to resolve. It's sine x, right? Okay, I plug. I think I will use this formula again, right? We have the formula there. Okay, so I will go to. This is 1 minus e cosine at 1, and then plus. So this use that formula is the difference between a, b of the function. u is e raised to the x v sine, see, between 0 to 1, right? And then minus that integral from 0 still 1, and this time is v, so it's sine x times du is here, ex dx. Okay, so let me simplify one more step, because we know this. We simplify one more step, you will see 1 minus e cosine 1. Okay, and this we plug in, I get the solution is e times sine 1. Okay, because 0 plug in is 0, and this is a constant number, and then minus. Okay, can we switch the order of this? And then you will find that this is exactly from the beginning, right? So a times b equals b times a. So I will just switch this again. Okay, I will just switch, and you will find, so this strange is 0 to 1 ex sine x. Why I say strange? Because this is what we need to solve. See, from the beginning you can think about it as the beginning. Now you go back to itself, but don't worry, we have something new. Okay, it's not just x equals x. It's just like as x equals a number like 10 minus x. This is equation. We can solve the equation. Let me highlight the equation for you. This is the equation. See, I highlight. Can you see it? This is an equation. From this equation we can solve for what we need is that one. Okay, and that means what? Easy to solve. You know how to solve. Okay, we're going to solve it, and then we get what we need is this one. See, 0 to 1 ex sine x dx. This one equal that plus this one both sides, you get a 2. Then divided by 2 you get 1/2. See, this is 1/2 of this constant term. 1 minus e cosine 1 plus e times sine 1. Have you seen? This is a constant number, which is the answer. Thank you.